Hello guys, welcome back to TechDose, and in this video we will look at count the hidden sequences problem, which is from Leetcode number 2145. Let's now look at the problem statement. You are given a zero indexed array of n integer differences which describes the differences between each pair of consecutive integers of a hidden sequence of length n plus 1. More formally, call the hidden sequence hidden. Then we have that differences at I equals hidden at I plus 1 minus hidden at I. You are further given two integers lower and upper that describes the inclusive range of values in the range of lower to upper that the hidden sequence can contain. For example, given the differences array to be 1 minus 3 and 4 and the lower in the range of 1 to 6 inclusive, the hidden sequence is a sequence of length 4 whose elements are in between 1 and 6 inclusive, right? Because there are 3 items in the differences array, and you know that n plus 1 items have to be present in the hidden array. Because if you look at the first item, if the hidden array was, let's say, a b c d, then the first item of the differences array will be equals to b minus a, second item will be c minus b, and the third item will be d minus c. So the size of differences array will be 1 less than the size of the hidden array. So if differences array is of size 3, the hidden array will be of size 4, right? Now in this case, if you put the value 3, 4, 1, 5 and 4, 5, 2, 6, then these two are valid sequences which are following the pattern of the hidden values. Because if you take 3, 4, 1, 5 and find out the difference, 4 and 3, it will be 1. 1 minus 4, which will be minus 3. And then you take 5 minus 1, that will be 4. So this is matching the given value 1 minus 3, 4, and the same goes for 4, 5, 2, 6. But it will not be true for 5, 6, 3, 7, and it will not be true for 1, 2, 3, 4. Because if I look at, let's say, 1, 2, 3, 4, then 1, 2, 3, 4 will be giving me the value. If you subtract, it will be 2 minus 1, 1. If you subtract, it will be 3 minus 2, 1, and if you subtract, it will be 1. 1, 1, 1 is not matching with 1 minus 3, 4, and that is why this is not valid. Okay. So likewise, you can compare. We need to return the number of possible hidden sequences there are, and if there are no possible sequences, we need to return 0. Now, I hope the problem statement is clear. So in this case, again, if you look at the example with 1 minus 3, 4, which was already explained with the lower and upper value 1 to 6, then there will be two sequences. I don't need to find the sequences. I just need to return the count of valid sequences, right? Now if you try to generate all possible sequences in the range of maybe low to upper, then you will have to try all the start point with the given low to up value. That means one time you will put in the array abcd, which is the hidden array, you will try to put a with 1, then the next time you create a sequence with 2, then with 3, and so on until you reach the upper value 6. So if the length here is n, and if n number of options are available here, then you are going to have order of n square time complexity for generating all possible sequences. And then you have to check if it is a valid sequence or not a valid sequence. So at least order of n square time complexity will be required if you try starting with all the values from lower to upper, provided upper minus lower is same as the size of the difference array. So in this case, the difference length is n, and n is maximum 10 to the power of 5. Okay, lower and upper value range can be 2 times of 10 to the power of 5. So they are almost similar. So you can say that total complexity in generating all the sequences will be n square, which is 10 to the power 5 into 2 times of 10 to the power 5, which is 10 to the power 10 approximately, which is way beyond your 10 to the power 8. So this will definitely give you a TLE, because this will require more than 1 second to run. Fine. Now once you have understood this, I want to solve this problem in possibly better than n square and maybe n log n time complexity, if I can do that, right? So our expectations are clear. Now let's look at an idea for solving this problem. The idea is, given the difference array, which is 1, minus 3, 4, minus 1. If you assume the hidden array, then it will have one extra size than the difference array. You know that, right? So let's say it is a b c d e. Then 1 is representing b minus a, minus 3 is representing c minus b, and so on. Minus 1 is representing e minus d. Fine. So these are the representations. Now if I assume that the low is 3 and the high value is 9, then how can we form the valid sequences? I can actually try forming the valid sequences. I can try with 3, starting with 3. That means assigning a to 3, or assigning a to 4, assigning a to 5, and so on till 9. And try to see which of the starting points are actually giving the valid sequences. We know that if we try to do that, then it will give me order of n square complexity. And that is something we cannot afford. So what we have to do here is, let's assume that the first item is x. Then what will be the second item? What will be the second item? You see, the value of b minus a is already given as 1. That means b must be 1 greater than a, so I will write x plus 1. If you look at the third value, the value of c minus b is already given as minus 3. That means c must be 3 values smaller than b, so x plus 1 minus 3 will be x minus 2. And similarly, what will be the value of d in terms of x? D minus c is 4, that means 4 greater than c, so x plus 2. And what will be the value of e? E minus d is minus 1, that means 1 less than d, so x plus 1. I have already given it in the graphical representation, you see. If the initial value assumed is x, second value x plus 1, third value x minus 2, fourth value x plus 2, and the fifth value being x plus 1. Now, in this case, you can realize that if I want to find the bound of this entire sequence, what is the highest value? X plus 2. What is the lowest value? X minus 2. So what is the range of this entire sequence? So the range of sequence starting with x is x plus 2 minus x minus 2, which will be 4 range. It is inclusive range, right? You can add 1 to it, but I will say that the range is from x minus 2 to x plus 2. Now if you look at this range L and H, then this range is almost 6, which is 9 minus 3. Again, you can add 1 to it to make it inclusive. So it is 9 minus 3, which is 6. Okay. Now it would be impossible to get any sequence if this bound, which is h minus L, is less than this bound range, which is x plus 2 minus x minus 2, which is basically your max value in the sequence minus the min value in the sequence, provided you are starting with x. You can easily find it is 4. If this 4 was actually less than this bound value, then it would be impossible to get any sequence and I have to return a 0. But in this case, it will be possible. And if you assume the L value 3 here and the H value 9 here and create two parallel lines, then if I bring this white curve and fix this x minus 2 to this L point, then let's assume that the x minus 2 min value is assigned the 3 value. Then where will the max value range, where will it be present? You add 4 and it will be present at 7, right? So if you bring this curve here somewhat like this, right, then you will find that the min value x minus 2 point will be at 3 and the x plus 2 point will be at 7. Now without changing the curve, how much you can move it up and down? How much you can move it up? Since I have fixed it to the baseline, min value to the baseline, I can move it up until the max point can hit the highest point, which is at 9. So how many points, integer points, is it covering? It is covering 7, it will cover 8 and it will cover 9. So that means I will be covering 3 slots. Okay, this curve will be covering 3 slots, 7, 8 and 9. So you can move it up like this. If you keep it at the base point, you can move it up by 3 points, 7, 8 and 9. Fine. So that is how you can say that there will be 3 possible sequences. One starting with a given value x, and what will be the value of x is, if x minus 2 is 3, then x value will be 5. Okay. So one sequence will start at 5. If you move it up by 1 time, it will start at 6. If you move it up by 1 time, it will start at 7. So the sequences starting from 5, 6 and 7 will give you valid sequences, and therefore the count answer will be 3. Fine. So the goal here is to get the valid hidden array such that we don't go out of the LH bound, and we need to count the number of hidden array which is possible. So you can find out the sliding range by taking the bound, which is h minus L value, which is 6, and subtracting the range, which is x plus 2, that is the max value minus min value of the entire sequence, which is 4, and adding 1 because you want to make this range inclusive, right? So that's why the answer will be 3 in this case. I think you have got the entire solution idea now. right? So let me show you a dry run quickly. Let's assume that our given array is 1 minus 3 4 1. So you know that our hidden array will be having 5 size. Now I will just be tracking the min value. Let's say my initial x value will be starting at 0. So my current value starts at 0. I will be tracking the min value and the max value. This will be tracking the minimum point in the curve and the maximum point in the curve. So let's do that. If you see 1, then 1 will be added. So my min value will not change, but my max value will change to 1. When you see a minus 3, then this becomes minus 2 by adding it. So min value will become minus 2. When you see a 4, this will become 2. So my max value will change to 2. When you see a 1, then this value becomes 3. Then my max value becomes 3, right? And then we are done. When we are done, we know that the max value is 3, min value is minus 2. So what will be the range here? Max value minus min value? It will be 3 minus minus 2. So that will be 5. What is my L and H assumed? 3 and 9. So my bound will be H minus L, which will be 6 here, right? So I can say that 6 minus 5 will be the gap plus 1, because I want to make this range inclusive. So that will be giving me 2. So I will have 2 valid sequences in this case. So I think it is clear. Now, if you follow this process, the time complexity definitely going to be order of n, and space complexity is going to be order of 1, because we are just using 3 variables. Now it will not be always possible to return a certain number. Maybe sometimes it will not be possible to make the sequence, and that will happen when the min and max range is actually greater than your H and L range, right? As I mentioned. So in this case, let's take an example, 4 minus 7 2, and if I start from this first item, then I will be adding 4. The min value will not change, max value will change. When I add minus 7, then this will become minus 3, my min value will become minus 3. When I add 2, this becomes minus 1, and nobody will change. And we are done. When we are done, the range that we find, max value minus min value, will be 4 minus minus 3, which will be 7. The bound range here is 6 minus 3, which is 3. So if the bound range is only 3, but the curve that you form will be having max point minus min point range to be 7, then how will you fit this curve within the bound? It will not be possible, right? So in such cases where the H minus L minus this value is actually negative value, then you will be returning 0 in such case. Otherwise, don't return a negative value for the count. If it is not possible, return 0. If it is possible, return the count value. So that's it. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the differences array, lower and the upper bound, and I will be taking a long integer gap because the range was already 2 times of 10 to the power 5. From minus 10 to the power 5 to 10 to the power of 5, right? And if you add it 10 to the power 5 times, then maybe there is a chance of overflow. So it's better to take a long integer. You can take minimum value to be 0, maximum value to be 0, current value starting to be 0. I will be iterating through all the items and add whatever item I see, minimize the min value, maximize the max value, and at the end I will be counting how many sequences are possible. And if the sequences are positive, then I will return it. Otherwise, for negative or 0, I will definitely be returning 0. So this is the entire code, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.